Time for 1619 pretest. Again, make sure that this video is going to go, make sure that you stop the video because it's going to go pretty fast. I'm going to run through everything that we talked about 16 to 19, and I don't want the video to be 30 minutes long, so we're going to run through it quick, but you do not need to watch this video step by step. If you understand a section, skip to the next section. That's the whole idea behind it. Determine the domain and range. Domain is x's, range is y's. So the domain in this case, I've got a -3 for an x, I've got a -1, and I've got a 2. The range, there's a -4, a 0, a 1, and a 2. Question is the function, does each x value only go to one y value? Is there a repeat in the x's? And the answer is there is a repeat, so it's not a function. The mapping, well, we've got domain is -3, -1, and 2, so we put the x's over here and the y's over here. -4, 0, 1, and 2. 2 went to 1, and I'm getting that from my ordered pair. So 2, 1 is my ordered pair. -3 went to 0. I have -1 that goes to 2, and I've got -3 that also goes to -4. Now you can clearly see that the x value repeats, goes to more than one thing. Number 2, identify the domain and range. Determine if it's a function. Remember that we want the domain to be written like this. So on both of them it's the same. We want the range to be written like this. Both of them it's the same. Let's take a look at the domain. So for part A, this goes forever left and forever right. So we're going to say x belongs to the real numbers, or it's all real numbers. Okay. On the second one, if I follow this along, it's got a bunch of jumps in it, but ultimately it's connected the whole time. There's open circles and closed circles, but there's always a closed circle at where there's an open circle. So this actually is that x belongs to the real numbers also. The range, how far down and how far up? Well, for A it goes forever down and forever up. So I'm going to say that y belongs to the reals. However, in B, when I look at the range, it does not go forever down and forever up. This graph actually stops right here and right here. It doesn't go any higher or any lower than that. So it goes from -5 to 7. We want to start at the smaller number. So it goes from -5, and it is equal to -5 at some point. There's an open circle there, but the graph is solid in other parts, so it's actually included. And then that's less than or equal to y, less than or equal to it stops at 7. Okay, so I want to make sure that that I'm plugging that in. It's got a stopping point on both sides. So then the question is it a function? And I can decide with a vertical line test that yes, the first one's a function. And I also can decide with a vertical line test that the second one is as well. Even though when I draw a vertical line here, it looks like it goes through 2 points, only one of them is included. That's the one that's included. So it actually is a function. There's only one point that that vertical line goes through. Determine whether or not the graphs are function. That's a vertical line test. This is yes. This one's no. And this one's yes. Each point, that graph continues going on to the left and to the right. Number 4, evaluate the function for each one of these parts. So use correct function notation. So I'm actually looking at this problem looking a lot like this. Okay, so I'm plugging in all of these values in terms of what these are. So this is correct function notation. G of -4. Now I'm not plugging it into an equation because there's no equation. I'm plugging it into the graph. So I plug in G of -4. Well, -4 gets me a point down here at -3 on the graph. G of -3 gets me a point down here also at -3. G of 0 gets me the point up here. And although that's off a little bit, we're going to go with that that's a solid number 4. G of 2, again, the same idea. We're going to go with solid number 1. G of 4, same idea. I should just shift the graph over. G of 6, goes up there to 5. So look at the whole numbers. If it falls in between, you can go with halves. So go with whole numbers or halves numbers when we're looking at the graphs that I make. Okay, here's the same thing except that I'm plugging in these numbers into an equation. Let me just simplify that one or make it clear a little bit more. F of -4, I'm using the f function and I'm plugging in -4. So that's -4 goes in there. 4 times -4 is -16. -16 minus 8 is -24. H of 3, so I'm using the h function. So I've got 3 times 3 squared minus 2 times 3 minus 3. 3 squared is 9. 9 times 3 is 27 minus 6 minus 3. 27 minus 6 is 21. 21 minus 3 is 18. I was going to write -18, but it's not negative. It's a positive. F of 7, so I'm taking 4 and plugging in 7 for x. 7 times 4 is 28. Minus 8 is 20. And h of -2, 3 -2 quantity squared minus 2 times -2 minus 3. So I've got -2 squared. That's a positive 4. Don't let your calculator lie to you. 4 times 3 is 12. -2 times -2 is 4. And minus 3. 12 plus 4 is 16. 16 minus 3 is 13. Number 6, provide an old and new table. So this is ordered pair tables like this. I just couldn't get the tables to be in there. And so I'm going to pick some on the old graph. I'm looking for places that these cross on the crosshairs. So I've got -5, -3. This one's not a good point. Right here, that's not a very good point. It's not kind of in the middle of places. Right? So I'm going to take this point right here, which is -3, -3. Then I'm going to take this point right here, which is 0, -2. And then I'm going to go with this one, which is 1, 2. And then I need one over here somewhere to the right so that I can finish this graph off, which is 6, -1. I'm going to move this 3 units to the left and 2 units down. So I'm going to take and 3 units left. It means that I'm going to take each one of these points, and the x is going to be subtracting 3. That moves it to the left. And moving it 2 units down, that means I'm going to subtract 2 from the y's. So when I go through this, all I'm really going to do is take the x's, the -5, and subtract 3, which gets me to -8. The -3 and subtract 2 to gets me to -5. Okay. Now, because I don't want to keep going back and forth, that's the whole idea behind it. I'm going to do just the x's, and then I'll move on to just the y's. So just the x's, -3 minus 3 is -6. 0 minus 3 is -3, 1 minus 3 is -2, and 6 minus 3 is 3. Now the y is -2, subtract is -5, -2 minus 2 is -4, 2 minus 2 is 0, and -1 minus 2 is -3. So now I'm going to plot these points. I've got -8, -5. Well, that one's off the graph. I'm not going to worry about that one. Okay, but I know that this goes forever to the left, so that's okay. -6, -5 is this point right here. And I know that that goes forever to the left. -3, -4 is right here. And this went up a little bit after that. Then -2, 0 is right here. And 3, -3 is way over here. Now when I look at this, I look and I say, oh, wait a minute. This doesn't look like I did the right thing. So the graph doesn't match exactly. So let's take a look at why that might be the I can tell that the point that's wrong is this point right here. So let's check and make sure that that point, which is this one, I did the math right. So 1 minus 3 is -2, that's right. And then 2 minus 2, that's 0, that's right. So maybe I just didn't plot it right. -2, 0 is actually right there. That looks better. It's got a nice sharp jump in there, and then this comes over like that. So the graph should look exactly the same. If they're not exactly the same, just in a different place, then you have issues. Okay? And fix the issues. Reflect over the x-axis. So I've got an old x and y. This one doesn't have quite as many points, so I'm going to go -6, -2. It's got a point up here, -1, -2. It's got a point down here. That's 1, -1. And let's take this point over here, which is 6, 3. So my new x and y, I'm reflecting over the x-axis. So what's happening is that each x value is staying the same, and the y values are going to become the opposites. So this is really -y. So all the x values stay the same. I'm not doing anything to those. I'm not moving it left or right at all. I'm just reflecting over the x-axis, which means I'm flipping it upside down. The y's are changing. So this is going to be 2, this is going to be -2, this is going to be 1, and this is going to be -3. Okay, so I get -6, -2, -1, -2, 1, 1, and 6, -3. And the graph's going to look the same. These two connect, these two connect, these two connect, except that the graph is upside down. It should be the same graph, look the same, except upside down. When we get to 7 here, for the following functions, identify the parent function, describe the transformation, and graph it. So the parent function, this is linear. If you made a straight line like that, that'd be fine. The parent function, this is quadratic. If you made a U shape, I'd be okay with that. This is a square root. If you made a graph that looked like that, I'd be okay with that too. The transformation, I've got a +2 on the outside, so that goes up 2. Okay, so I've got a straight line. Here was my parent function. I'm going to just move that up 2. You do not need to draw the parent function in, but you have to draw the correct the family function. The transformation on g of x, I've got a -4 on the inside, so that actually moves it right 4. I've got a negative on the outside, so that reflects on x-axis. If you set upside down, I probably will take that, but you need to know that it's a reflection on the x-axis. So my normal quadratic looks like this. I'm then going to move that quadratic to the right 4. And I'm going to flip it upside down. So it should look like this. My square root. So my square root usually looks like this. And I'm going to do two things to that in terms of the transformation. I've got a +3 on the outside, so that's up 3. And a -2 underneath the square root, which actually means that I'm going to move this right 2. -2 on the inside means that I'm going to move it right. So I'm going to take this and move it up 3 and right 2. So up 3 and right 2 gets me to here, and the graph's going to look extremely similar to the original. Okay. That's 1.6 to 1.9. That was everything we did. Make sure you go through and study it. Use this as an answer key. And then be ready for your test when we're going to take it.